All right, this review is for end of course 2A, which means it's going over the questions that are like 11 through 20 on the final exam. So starting with number 11 right here, you can see that they are giving us 2 points, and you can see those right here of -6 comma -1 and 3 comma -2. And it's asking us for the equation of a line that's going to go through those 2 points, and also they're telling us something about how they want that to look. They want us to use something called point-slope form. All right, so to use point-slope form, we need 2 things. We're going to need a point, and we're going to need slope. Now we do have 2 points right there, so that takes care of that. But we're going to have to figure out the slope, and we're going to do that using the 2 points. So off to the side here, I'm going to go ahead and do that first. So my slope formula that I'm going to use right here, I'm going to find the difference of the y's and divide that by the difference of the x's. Now you're seeing all these x's and y's with little 1's and 2's. Where are those coming from? Well, this -6, that's going to be my x sub 1, and the -1 that goes with it is my y sub 1. To the right, this is my x sub 2 and my y sub 2. So I've got 4 terms, and here's where they're going to go. So right underneath there, I'm going to go ahead and plug in things. So I've got the y sub 2, which is the 2, minus the y sub 1. It is a -1, so I'm going to write it like that. You could put that in parentheses if you want. And then underneath, I have x sub 2, which is 3, minus, and I've got another negative. All right, so we need to simplify that. I'll go to the right here. So 2 minus -1 is going to become 2 plus 1, or 3, and 3 minus -6 becomes 3 plus 6, or 9. And I can reduce that to 1 over 3. So this is my slope right there. Now that I have my slope, I can use the point-slope formula, which is going to look like this. Y minus y sub 1 is equal to slope times x minus x sub 1. All right, so we now have everything we need. I need to put in a y sub 1, which is right here, x sub 1, which is right there, and I figured out the slope. We're not going to touch the y or the x. So we have y minus y sub 1 was -1 equals the slope I figured out was 1/3, and then x minus x sub 1 was -6. And because we have these double negatives, we should really write it one more time to become y plus 1 is equal to 1/3 times the quantity x plus 6. And that would be my answer right there. You don't have to distribute because it does say write an equation in point-slope form. That is point-slope form. All right, moving on to the next one here. We have to come up with the slope of a line that's parallel to this line. So first off, you got to remember something about slopes of parallel lines, and that is that they are the same. So parallel lines have the same slope. So I'm just going to write same slope right there. So basically, we just have to figure out what is the slope of this, and then we'll have the slope of a parallel line. How do we get slope? Well, we're going to put it into slope-intercept form. So that's all about getting it into something that'll look like this. Y equals mx plus b. And m is the thing we're actually looking for. So over here, I've got to move this 2x. So I'm going to subtract it from both sides, like so. That's going to cancel right there, leaving me with 5y is equal to, and I'm going to write the x term first, because that's how it looks here. Now this is not going to be my m yet. I still have to get y by itself, so I'm going to divide everything by 5 to to get y is equal to negative 2/5 x plus 4/5. Now the only thing I'm really caring about is this right here. That is the slope, so that's actually my answer right there. So I'm just going to put answer. That's the slope not only of this line, but also of any line that's parallel to it. Next up, number 13. It says we have to find the inverse of this function. And nice little thing with the inverses are that you just have to switch the y and the x and then solve for y. Right now it's already solved for y, so I'm going to switch them. So this y is going to become an x, and this x is going to become a y. All right, now we have to get y by itself, so I need to subtract 4 from both sides. So I'm going to get x minus 4 on the left, and over here I'll have my 4y. And then, once again, I need to solve for y, so I'm going to divide everything by 4. And I'm running out of space, so I'm going to do this and come on over here. So on this side, remember there's a 1 right there, so that's like 1/4 x minus 4 over 4 turns into a 1 is equal to y. Now, keep in mind your answer key probably is going to have the y on the left, so we can just flip everything. Like so. So this would be my answer to that one. Number 14. You can be creative on your own. With this, the test will have different scenarios, and you have to look at them to see what might make sense. So I'm going to make up one right here. But this is what's known as a positive correlation. So basically, as x is getting bigger as it goes to the right, y is also getting bigger. So in other words, x is increasing and y is increasing. So you just have to think of something that might happen with. So one thing I thought of would be temperatures. So I'm just going to put TEMP for temperature, and then over here, how about something like shorts? Meaning, the warmer the temperature it is, the more people are wearing shorts. Okay, so the scenario would just be something like, as the temperature increases, comma, more people wear shorts. So you can just leave it like that. Last one in this recording, circle each arithmetic sequence below. So you have to remember that an arithmetic sequence has a common difference. So look for common differences. What does that mean? Well, if you're looking at the different numbers from one number to the next, let's say this one, for example, -5 to -2, you would add 3. So then you see if it's always adding 3. That's what makes it a common difference. So -2 plus 3 is 1. 1 plus 3 is 4. 4 plus 3 is 7. So I'm going to go ahead and circle Roman numeral 1. Next one, 2 to 4. Well, 2 plus 2 is 4, but 4 plus 2 is not 8. So this is not an arithmetic sequence. Next one, 16 to 11. Looks like I subtracted 5. So 11 minus 5 is 6. 6 minus 5 is 1. And 1 minus 5 is -4. So I am going to circle that one. And by the way, if you want to think of those common differences, I probably should have put them here. This one, the common difference was a +3. This one, the common difference was a -5. Now, I've got to look at the last one here, and it's meant to be a little tricky here. So 1/3 and 2/3, well, it did go up 1/3. But this might throw you off, because you see a 1 here, but if you think about it, if I added a 1/3 here, I would have 3/3, and that reduced to 1. But if I had written it as 3/3, and I add a 1/3, I'd have 4/3. And if I add a 1/3 to that, it's 5/3. So this is an arithmetic sequence as well, and the common difference is 1/3.